Welcome to the Sand Science Experience, your source for the most current and impactful research and preprints in science.
Great to be diving into this today.
Absolutely. And hey, please take just a moment to like this deep dive and subscribe. It really does help support the Sand Science Experience.
It does.
So today we're diving into something fascinating, really reshaping how we think about aging.
Yeah, the surprising role biological sex plays in how our bodies respond to, well, these pro-longevity interventions.
Exactly. Our mission is to unpack these groundbreaking findings from the National Institute on Aging's Interventions Testing Program, the ITP.
Right, and understand why acknowledging sex differences is just so crucial if we want to develop effective drugs.
Let's start with the ITP itself. It sounds like a massive undertaking.
Oh, it is. Launched back in 2004, so, 2 decades of work.
Wow.
It's this multi-site effort rigorously testing compounds, the goal, extend lifespan, delay aging.
And they're not just using any mice, right?
No, that's key. They used over 30,000 UMHE3 mice. These mice are bred specifically for wide genetic diversity.
So more like the human population.
Precisely, which makes the findings, well, incredibly relevant to us. They've looked at 54 different compounds over this time.
Okay, 54 compounds, 30,000 diverse mice, 20 years. What's the big headline? What really jumped out?
Well, the really striking thing, the consistent pattern, was that most compounds that actually extended lifespan, they worked primarily, or sometimes only, in the male mice.
Only in males. That's huge.
It is. It's not some small difference. It strongly suggests the basic biology of aging might be fundamentally different between the sexes.
Sexually dimorphic, as they say.
Exactly. And even things like the best dose, or when you start the treatment, that often varied between males and females too.
So if these potential life-extending treatments often work better, or maybe only, in males, what does that mean for finding things that work for everyone? Are we kind of missing half the story?
That's the core question, isn't it? It really forces us to rethink how we approach longevity research from the ground up.
Okay, give us some examples. What drugs are we talking about?
Right, let's look at specifics. Take rapamycin. Now, this one is often called the most effective pro-longevity drug overall.
Okay.
But here's the twist. At certain doses, rapamycin actually showed a stronger effect in females.
Oh, interesting. So the opposite of the main trend.
Exactly, like starting it early, at 9 months. A lower dose boosted female median lifespan by 17%.
Wow. And males?
Just 3% at that dose and timing. Even at a higher dose, females still got a bigger benefit. And interestingly, for males, the highest doses started later in life actually reduced the positive effect. It hints that maybe females need or can tolerate higher doses than males for the best outcome with rapamycin.
That's fascinating, a total reversal. What about other big ones? Was rapamycin just an outlier?
It does seem somewhat unique in that respect. Let's look at acarbose. This is an FDA-approved drug for type 2 diabetes. It works by reducing glucose absorption in the gut.
Okay, I've heard of that one.
It extended lifespan in both sexes, which is good.
Right.
But the effect was markedly greater in males. We're talking a 17.5% increase in median lifespan for males versus about 4.8% for females.
17.5 versus under 5, that's a big gap.
A huge gap. And for males, they found starting the treatment early in adulthood was really important for that maximum benefit.
So rapamycin potentially favoring females at times, acarbose strongly favoring males. What else? You said most favored males.
Yeah, many others primarily or even only extended lifespan in males. There's nordohydroguaric acid, let's call it NDGA, it's an antioxidant.
Okay.
And 17-alpha-estradiol, that's a type of estrogen considered non-feminizing with some neuroprotective and metabolic benefits. But both of those mainly helped the males. And another diabetes drug, canagliflozin, also showed male-specific benefits.
And wasn't there one that was actually bad for females?
Yes, that's a crucial point. One compound, 16-alpha-hydroxyestradiol, another estrogen variant, it actually shortened female lifespan while extending it in males.
Wow, that's concerning. So, okay, why? Why these huge differences? Is it hormones, metabolism, how the drugs are processed?
It seems to be a mix of factors. Hormones, definitely. Testes versus ovaries, the hormones they produce, they clearly play a role.
Makes sense.
Then there are metabolic differences. As these male mice age, they tend to get more insulin resistant, their glucose levels go up.
Right.
And many of those drugs that worked best in males, like acarbose, actually improve insulin sensitivity or lower blood glucose.
Okay. And rapamycin, the one that favored females sometimes.
Interestingly, rapamycin can actually induce some insulin resistance, so it's working through different pathways, it seems.
And what about how the body handles the drug, pharmacokinetics?
That's also part of it, yes.
Yeah.
How drugs are absorbed, where they go in the body, how they're broken down, how they get excreted, that can differ between sexes. Like, they found females had lower levels of NDGA in their blood plasma compared to males.
Okay, so the drug journey itself is different.
Could be, yes. It all contributes.
This really changes the perspective, doesn't it? It's not just academic curiosity. This has huge real-world implications.
Absolutely.
I mean, think about historical drug trials. They often focus mainly on males.
Right. They did, historically. That's been changing, but there's a legacy there.
Could that legacy, that focus on males, be why we sometimes see women experiencing more adverse drug effects? Or why some treatments just don't seem to work as well for them?
It's a very strong possibility. It highlights a critical gap. If we want treatments that work safely and effectively for everyone,
We have to study everyone, both sexes.
exactly. Understanding these sex-specific mechanisms isn't optional. It's essential for developing targeted, effective strategies to extend healthy lifespan geroprotective strategies for all people. It's not one size fits all.
Right. We need smarter trials, more inclusive research.
That's the path forward.
So what does this all mean for you listening? Well, recognizing that biological sex is a major factor in how treatments work is crucial.
Yeah, it pushes us beyond generic solutions.
Towards a future where, hopefully, anti-aging interventions can be tailored much more effectively to our individual biology, including our sex.
A personalized approach to longevity.
Exactly. Well, that's our deep dive for today. Remember to like this video and subscribe to the SAN Science Experience for more current and impactful science insights.
Your support keeps us going.
Until next time, this has been the SAN Science Experience.